Okay, so we are starting chapter 11. If you are thinking, be quiet please. If you are thinking about what things you want to retake, we will not have another test, we will have a quiz. Okay, so, and then the things that we learn now will be on the exam and on the quiz. So, we are starting a chapter that involves something called limits. It's a pre-calculus topic, and it's very different. Okay, it's very different. So to get you thinking about things with limits, I just want you to discuss, take a minute or two to discuss whether you think these things are limited or not. Okay, limited or not limited. So take a second. You can talk to the person sitting next to you because I know some of you are very good at that.
Is that like a
Yeah, it was.
anyone specifically? Don't say name.
Don't say names, but names. Hey, take a second, see if you what you think about this.
What am I gonna miss?
Hold on.
Every time I'm on, we got something to do. I got a test in Spanish. I'll just put my mark in this class. This page here because stop. You know, literally 1.5 chapters.
Javon.
No,
Seriously.
Eventually there is
All the colors are already made.
No, you just can't. You just add shades on. There's a limit.
Okay, so now that's the same thing. I'm broke. What do you mean stop?
Javon, have you even discussed anything? You're just yelling about random stuff.
We did discuss it. We went to the whole thing at the beginning.
Put zero thought into it.
Yeah, no, we didn't. I literally was thinking about it before he did it. A plane can't go in outer space.
No zero amount of horsepower.
Your cars don't like.
Cars don't take the
I can demonstrate it. I can just keep
your tires will the local eat your tires.
Oh, your tires will eat the road. See, what are they?
Okay, so how high a plane can fly? Limited or not limited?
Limited.
Agreed. Why?
The engines won't work.
The
air is too thin.
Yes, you guys, the engines won't work because the air is too thin. Because they are based on combustion, right? And combustion needs oxygen.
Do you think that it would freeze first or would it like run out of air?
Don't know.
Yeah, but they have like stores of oxygen.
No, an airplane's not. Yeah, a rocket's a bit different than that.
Rocket's different.
They store air.
Because the fuel in a rocket is liquid oxygen.
What about solid?
I don't know.
Solid oxygen.
There's solid state engines. Because there's nothing about air.
I don't know anything else about this, so we're gonna move on. Okay, how about the second one? The amount of liquid that can be put into a cup.
Not limited. Because you can keep pouring it into that cup.
It's not in the cup.
Yes,
It never said it has to stay in the cup.
You said in.
In the
Into.
In.
No, not into.
No, I'm going limited because
say
as soon
into.
as,
No, the amount of
no, I'm
liquid.
going with Ellen. As soon as it starts overflowing, it's not in the cup.
Yeah, but if you got like the same lead thing that's going in.
Yeah, but it's talking about the amount of liquid that you put into the cup, not the amount of liquid in the cup.
Yeah, but
And
if
it
you
says
put it in the cup, it
in
says
the cup. Don't be put up.
It does not say in the cup, it says into.
you cannot put more into the cup with a cup.
Connor, if you sit there and you're at the slushing machine in Speedway and you sit there and you just leave it on, are you gonna get any more than you leave it on?
No, but I'm still
Exactly.
putting, I'm still putting,
Exactly.
no, but I'm still putting more into the
Push.
cup though.
Number of shoes you can buy.
The number of shoes you can buy.
Unlimited.
Limited.
Okay.
Not limited.
If it's, I think it's limited limited by several things. By, first of all, you run out of money.
Credit cards. You just keep getting new credit cards.
Excuse me,
How
credit
people
cards have
go.
limits, that's the purpose of it.
We're adding factors here.
What?
We're adding factors.
Welcome to real life. Welcome to real life. They do a credit check on you, and eventually they'll be like, you have 50,000 credit cards. We're not giving you another one. Limited. What else? What else?
There
The amount of space you have to put on the shoes.
This is
Materials.
This is fully.
you can buy them and just throw them away.
Okay, then go with materials.
Okay.
I mean, Earth has a lot of wood.
Now, Christian is Dutch and he's wearing wooden shoes. So,
The amount
okay.
of like shipping,
Yeah.
because eventually you'll
You
run
could
out of
just
supplies
like
and stuff.
Yeah.
create infinite chains of just trading and buying shoes from each other.
See, this
Wouldn't run out
is
of money.
this is
wouldn't
more
run out of
logical
space.
than Connor's keep pouring into the cup.
Okay.
No, you guys just don't see it.
How about the next one?
Two to go.
Unlimited.
Clearly, it's limited based on the amount of supplies that you
We're
have.
talking about
Yeah, we're talking about the number between 0 and 1.
Unlimited.
Unlimited.
Not limited.
unlimited, right? There are infinitely many. You guys, that's such a weird concept because 0, 1 is such a small space on the number line, but there are not only infinitely many numbers on the number line, there's an infinite number of them between 0 and 1. Just crazy to think about. Like it'll explode your mind if you think about it too long. How about the amount of colors that can be created?
Clearly,
Unlimited.
Limit, right?
It's the same concept of the number line where you can have an infinite solution of like a percent
Yeah, but
of red.
Not limited.
Like if you take one color and you add 0 point infinite number and then 0.1% of red to it, that's a different color.
Yeah, but
Yeah,
we're limited between like the 1,000 spectrum for like all primary colors.
Oh, did I say that we could see it? Did I say we could see a difference? No. Didn't.
What is this?
I would like you to know that last year, Mason, when we did this, Mason argued with me forever about this. He was like, it's limited.
It's
And
100%.
it's not. It's not.
It's gotta be. If Mason says it's limited, it's limited.
If we're
That's a fact.
including
These
colors,
means nothing but true.
if we're including colors we can't see, then it's not.
It's not limited.
But if
Or even the very, like you might, like we
The
might add
concept of
the,
something being limited doesn't have to be perceived.
So aliens are real.
it has.
What? Yeah, where are we going?
So anyway, if you go with what Grayson said, like you can make it atomically different, right? Like I can add one more atom of red and my eyes aren't gonna see it, but it's technically different. So I would say that it is limited. Unlimited, sorry. Maximum speed your car will go.
Limited.
It's limited. It's limited by a lot of different things, right?
I can.
What are the limiting factors there?
Road space.
Engine power,
Aerodynamics.
road space, strength, aerodynamics, engine size,
yeah.
how
How many cops are trying to pull you over?
many cops are trying to pull you over? Okay, that was not really mine. Depends. Depends on your motion, if you want to get thrown in jail.
1,000 miles an
Oh,
hour.
yeah.
Your car would just.
No, but you can't.
Yeah.
It's like Michigan.
But then you're like going down, if you're like using like a random, then you're a spaceship.
Right. I know.
I feel like that 18-foot, you're like just before you get to it, you're doesn't matter if you're going 1,000 miles an hour.
There's a difference.
I guess.
No, but it's got more downforce and going that fast. It's used to be going. Trucks got more resistance. And trucks got more clearance stuff too.
They're still talking about it.
Yeah,
What if you strap a rocket on the back of your car?
No, we're talking about how fast you need to go to clear an 18-foot mile.
The things that we do in this class.
18 miles per hour.
That is math related. Okay, but you gotta cross your town.
Jordan could clear an 18-foot Hey dude, Jordan's a goat.
Okay, so
It's one-sided.
you should have a graph paper that I gave you.
Yep.
So I want to give you a super, super basic idea of how calculus is different than pre-calculus. And I'm going to rewind you to when we started talking about angles and trigonometry. And I talked to you about the difference between angles in geometry and angles in trigonometry. So angles in geometry, it's just an angle that is there and you measure it and you figure out how big it is. But if you remember, we talked about dynamic angle formation, right? Where you have two rays that are on the same thing and one of them just starts spinning, right? And then you measuring how far did it travel. So trigonometry is a little bit more about the motion of the angle, how far did it travel, and geometry is about static, something that's there. And then you talk about it. That might not have helped at all. Calculus, let me go back. Up until calculus, all we do is like we did on the warm-up. We look at a graph and we say, this is what's happening at this one point, right? That's what we did. F of whatever, F of 3, F of 0, F of -6, what's going on in the graph. Calculus is a little bit more concerned, actually it's a lot more concerned about behavior. So not what is it, but how is it acting, okay? How is it acting? So calculus looks a little bit more at behavior. Let me show you the difference. So if in pre-calc stuff, I would say to you, what is f of 2? And you would say to me, what?
Not possible.
Nope. Oh, undefined. Did I say that earlier?
No, you said no solution.
Oh, no, I did not say no solution. Okay.
I literally said
NP.
Okay, I said not possible. Which I should have said undefined.
Well, I asked you the no solution, you said, well, what's the other answer? And I said a solution, and you just looked at me, so.
Okay, so we say that it's undefined. Okay, so that's actually the correct terminology is undefined. But that does not tell you, it does not tell you what's going on in the graph other than that there's nothing there. You don't realize that with just this information, it could be a lot of things. If we start talking about how is it behaving, what is it close to? What is the y value close to at x equals 2? The y value is close to 3, right? And so that idea of talking about what is it close to, what is the graph close to, what y value, is the idea of a limit, and it gives you a better picture of how the graph is behaving. Okay, and so what we do is we talk about this thing called a limit. And so I'm going to define that. A limit as how a graph behaves. And when I say that, we're talking about its y value. As x gets infinitely close to a given x value. Now, if you were to take calculus and look at, like, if you were to look in my calculus book, there is a very specific definition of limit, and it's ridiculously weird. It's hard to understand. This is the intuitive thing. If you understand what we're talking about, you're gonna be fine. We're looking at how does the graph behave, so it's a y value, as x gets very, very close to a given x value. So it has its own notation. Looks like this. This is a scribble. To a given x value. Okay, so let me give you an example of this. Like this is not going to have a letter here. This is going to be an answer. So this will be the y value, or your answer. This will be the x value that we're talking about. So you're looking, this is like where, it's the location that you're looking at. So if I was I'm gonna make it concrete for you. So I'm gonna name this graph F. and I will say the limit, I'll move my hand in just a second. The limit as, is how you would say that, the limit as x approaches 2, I'll write that down and also for you, of f of x is equal to 3. So you can see, here's the x value I'm talking about, here's the y value that it's approaching. Okay, it's not equal to. So a limit never means equal to. It just means if we're really, really close to it, basically, what does it look like? And so we would say this, the way we would say it is the limit as x approaches 2. That's how you would say that. The limit as x approaches 2. I'll give you a second to catch up. Everybody set? Okay, so we have something called a right-hand limit and a left-hand limit. You're never going to actually have to write that out again, because a right-hand limit is the limit as x approaches c, and there's a little plus up there. And then a left-hand limit is the limit as x approaches c with a little minus up there. So these little signs here, these indicate the direction, the x direction, left, right, that you're coming from. Okay, now I'm going to make this, we're going to do some of these and that will make it make a little bit more sense. Okay, so you have to remember that if it says +2, it does not mean that you're going to the positives. It means you're coming from the positives, okay, as opposed to coming from the negatives. Okay, so I want you to get out the graph paper I gave you, and let's look at the side that has 4 graphs on it, not the 2 graph side, the 4 graph side. Okay, I would not put away my notes yet because we're going to use them. Okay, we're going to add to them. So, for example, if we look at 1 on this graph, the limit as x approaches 1 from the right. I had people that had the worst trouble with this last year. I honestly don't know why. Look at 1. Go to the right side of it and start tracing. So I'm going to slow that down. Look at 1. I know it's 1 because it says 1 there. The plus means go to the right side of it. So here's 1. Hit the graph on the right side of it and then start going back toward 1. Because that's what this says. It's approaching 1, but from the right. What is its y value? 2. Okay, so pick the, that was the super simple definition in case you're confused. Pick the x value, jump to that side of it, wherever the graph is, and then go back toward, you're following the graph. You have to stay on the graph and go back toward 1. But that's what it means to come from the right. So then the limit as x approaches 1 from the left is what?
1.
1, right? So we're on the left side of 1 and we're going back toward 1. And so it is 1. So the thing about a limit is it doesn't matter if it's an open circle or a closed circle there. Okay, because we're not talking about if the graph is defined, we're talking about the behavior of the graph. So somebody who understands limit notation, like outside of this classroom, let's say, can look at this and go, oh, I know that this jumps from 1 to 2 at x equals 1. Not that you have to worry about that right now. So let's look at this one. Let's go the limit as x approaches -2 from the right, and the limit as x approaches -2 from the left. So this is weird because you end up with like, my negative got floaty, but there you go. Like you end up with the -2 minus, like that's a lot of negatives being flung around. Just remember that if it's up in the superscript area, it's telling you direction. Okay, limit as x approaches -2 from the right with the plus is what? -1, yeah. Right? Here it is. I'm on the right side. What's his y value? His y value is -1. Okay. -2 from the left, that means we're coming up this way toward the -2. What's his y value? Also -1. Okay, so I want you to try a couple of these here. Let's go the limit as x approaches 6 from the right, and the limit as x approaches 6 from the left. This is next door here. And then let's do the same thing with the -8. Limit as x approaches -8 from the right and the left. -8. And let's do the limit as x approaches -2 from the left. Okay, what's the limit as x approaches 6 from the right? 5, right. So we're coming towards 6 from the right, it's at 5. Okay, how about the limit as x approaches 6 from the left? 2. Okay, how about the limit as x approaches -8 from the right? Now, is it -6 or is it -3?
It's gotta be on -6. It's gotta be on the line.
Got to be on the line, right? Because you're jumping to the right of it and you're following the graph. So this is the part of calculus that's different. We don't care about this guy. We want to know how the graph behaves. Eventually we start caring about him again, but for limits, we don't care. We just want to know what's going on in the graph. The graph is really, really close to -6. Okay, how about from the left? Also -6. Okay, how about the limit as x approaches -2 from the left? 3. Okay, do you guys get what I'm throwing at you right here? Are we okay? Christian, you okay?
All right.
All right. Weston? Good. Andy? Okay. All right, so now, sometimes limits don't exist. Okay, sometimes the limit does not exist. So here you go. If the left-hand limit, well, let's write it. If the limit as x approaches c from the left is equal to the limit as x approaches c from the right, okay, so that's what all that is. It's like if I feel like we should get foreign language credit for math class when we get up this high in math. Okay, so this is the left-hand limit is equal to the right-hand limit. Then the limit as x approaches c of f of x exists. If these are not equal, these guys right here, the limit as x approaches c of f of x does not exist. Okay, and we write D and E for that because nobody wants to write does not exist 4,000 times. Now that's a lot, looks like a lot of mumbo jumbo, but it's extremely easy in practice. So sometimes, kind of like the undefined that we do when there's a hole in the graph, when there's that point in the graph, sometimes a limit does not exist either, but we don't write no solution and we don't write undefined. We write does not exist. Okay, it's different. So if we come up here, just a second, there we go, back to my graphs. If I were to ask you for the limit as x approaches 1 of f of x on this first graph, the limit as x approaches 1, I look at the left, which is 1. I look at the right, which is 2. Those are not the same. So because they're not the same, the limit does not exist. Okay, the limit does not exist. Notice that this guy does not have a plus or a minus on him. That 1 does not have a plus or minus on him. You still have to consider what's on the right and what's on the left. Look at it and be like, well, they're not the same. So this does not exist. Over here, the limit as x approaches 2, negative 2, of f of x. These two things are the same. So the limit as x approaches negative 2 is negative 1 because it behaves the same on the right and on the left. So you can see that I can give one statement, I can give one statement about how it behaves there because it's behaving the same on both sides. What? Right. If they're not touching, it doesn't. Pretty much. Right? So if you would look at hear what Eli said, he said, if they're not touching, the limit does not exist. If they are touching, the limit exists and it's that y value. Okay, so what I want you to do, this should be our last example, and then I'll give you homework time. I didn't think we'd get this far because they're so intelligent. Yep.
So if we could look at the graph and like they're not touching, do we have to go through all the?
No.
We can just say it does not exist.
Well, so it's going to depend. Like if I give you this versus if I say to you limit as x approaches negative 4 plus, you just have to answer the question. There's no work.
Okay.
It's literally just write down the number. Does that answer your question?
So does this mean that like
We don't like have to prove that it doesn't exist.
No, you do not. You might have, so not prove. There may be times when you would have to explain, but it would be a different kind of problem. It would say, does this limit exist? Explain why or why not. Okay, there you go. There's 4 of them.
Javon, the only reason why we got through the whole lesson is because you weren't talking through it all.
okay, and so wow, even
Yeah.
Do you have these done?
why see why do you do like that? How was it start?
I could do it all in my head.
Okay, so I want all over in order. Let's do limit as x approaches -4 plus. I'm not going to say what that is because I am also seeing if you were paying attention, I guess, or you get what I'm throwing at you. -2. Okay, so again, it's which direction are you on? You're on the positive side of -4, so not from that direction, but toward, like here and going that way. I just lost what I want to say. Limit as x approaches 2. Does not exist. Okay, so look at this guy's at 5, this guy's at -1. They are not matching up. The limit does not exist. Okay, how about the limit as x approaches -1? 4. So it doesn't matter if it's defined there. That's fine. It just makes life easy for you. You just go, it's at 4. Great. Okay, how about the limit as x approaches +4 of f of x? 2. Okay, questions on that? It's pretty easy. You just have to, like, it's just different. It's just different. So I am going to give you homework. It's not in the book.
Oh, all right, sweet.
Okay.
I'm so sorry, Ellen. Oh, great, it's package.
Hey, well, listen, let's be real. How long is it going to take you to do one of these problems if all you have to do is write down a number?
All of it, like,
Absorb that.
Okay, I'm gonna actually have you do all of it. Even if you're Gold Star Club, you have to literally like write down 34 numbers. It's fine. What? You can take off 34.
Yes.
Good. Let's do this. You can all cross off. Just a second, let me see what I'm on here. You can cross off number 6, 4. Sorry, I went out of order there. Yep, everyone. You can cross off 13.
And 45.
21.
45.
45.
Yep. 23. 27. Right. And then if Gold Star, and you guys can all cross off 34. So I get you one better, Eli. I cross off a whole bunch for everybody.
Thank you.
So it's 4.
Oh my gosh, Andy! 4,
Keep the number. Let's do it. 4, 6.
6.
-4. 21.
It's just 4.
34.
Yeah, I got all.
You got all. Does it give you a point for it?
Nope. Nope.
Just have to in the graph. Got it.
Yep.
Got it. Got it. That's.
Okay, this is a good time to ask questions, okay? So if you're not sure, please ask.
Well, this is for basketball, but if you are.
Which one are you doing?
Oh, we're 4. Oh, we don't have to know 4. Oh, wow.
That's why I crossed it off, because we haven't talked about
But
that
it's
yet.
all around number.
It's not. It's infinity,
I was in
so kind of.
ish, but